All right. We had all that time, and now you're going to ask right when I get ready to teach? All right. So, what if I said this? Would you agree with that statement right there? Yeah. What is this thing? Equals, okay? What if I said this? So really what I'm doing is I'm comparing, aren't I? I'm comparing two things. I'm comparing this with this. If they're exactly the same thing, we put equals. All right, so they're equal to each other. What if I did this? What if I put a 5 here and a 7 here? Can I put an equal in between? No. So what is 5 compared to, again, we're comparing. What is 5 compared to 7? It's less than, okay? It's less than, right. You're right, it is two numbers less than, but just in general, it's less than. Would you agree? We have a symbol for that. Do you remember the symbol? Yeah, teachers do the alligator thing, but that's kind of elementary way to do it. Here, I'll just show you where they got the less than and greater than thing from. So equals, let's try to make it a little, watch. What? Don't encourage him, Zion. So look, an equal sign, there's just as much space in between here and here. Would you agree? What if I did this? What if I took this and tilted it? Oops. I should have drawn this somewhere. Let me draw this down here. Let me draw down here so I don't grab that. Oops. It's because I clicked on that, on those words, and it got rid of the white. So there we go. Now we're ready. So watch. Everybody see this? So there's an equal sign. What if I took this and I tilted it and got them closer? And what if I took this and tilted it so it's closer? Do you see that? So look at the distance now between these 2 points. That's a lot what compared to this? It's a lot less, isn't it? So that's a less than symbol. Everybody see that? All right. What if I flipped it the other way? I think I have a thing here that will flip it. Flip it horizontally. There we go. All right. So check this out. Yeah, this left side, there's a greater amount of space in between here, isn't it? So this would be greater. Now, that means when we're reading it from left to right. So what could I put in here? 5 is what? Less than 7. Okay, it's not or equal to. Okay, it's just less than. 5 is less than 7. Would you agree? I could write it the other way. I could write it from right to left. Okay, so I could say 5 is what? Less than 7. It's not that much, but you got a symbol, so you don't have to write all that stuff, right? So you don't have to write that, but this is what we would say. I'll put it in quotation marks, okay, because that's what we would say. Or, now that would be the, like, quote, normal way of saying it, all right, from left to right, because we read from left to right. But you could say what? You could start with the 7 and say what? 7 is greater than, in this case, what? 5. Okay? So you could read it from left to right, or you could read it from right to left. Everybody see that? All right. So, but normally we would go left to right. Benjamin, you're going to be out the door, okay? And I already sent you out in the hallway the other day. So so it's not hallway today, it's office today. Do you understand that? I moved one person from you and you just can't resist, and you're getting everybody else. I've seen 3 people that have been distracted because of you. Now 4, because I've been distracted because of you, right? And I'm the one that counts more than anything, okay? So if you bug me, you're going to the office. You've already bugged me like 3 times already today. So we've got 5 is less than 7. So what we're going to do, this is comparison. That's what I want you to understand, a comparison. So we have a thing called the comparison property. It's kind of like, it's common sense. Okay, it's really nothing new. But they put it into a property. And so here we go. So comparison property. So this is what it says. It says, they make it look a lot more complicated than it really is. But there's a reason why we're doing this, because we're going to do something with geometry. Like right now, this is not geometry, but we're going to do stuff with geometry in a minute that hopefully you'll see where it comes from. All right, so if A equals B plus C, and let's just make sure C is not 0 and it's not negative. So we're going to say, and C is greater than 0. So as long as C is a positive number, all right, then, so this is an if-then statement, okay? If this is true, then A must be greater than B. You're like, okay, I really don't understand what that means, but let's put some numbers in there and let's see. It says if A is equal to B plus C. So let's take a number like 7. Give me two numbers that add up to be 7. 3 and 4? Okay, 3 plus 4. Everybody see that? Okay, so what does this say? If A equals B plus C, so that's the A, that's the B, that's the C. Is C greater than 0? Yeah, okay, so does it fit the if part right now? Sure, everything's good. What is the conclusion then? Then A, which is what? 7, must be greater than what? Than B, which is 3. In fact, you could also say 7 must be greater than what else? 4, okay? Because look, if these two things add up to be 7, everybody see that? So if it takes these two things to add up to be 7, then the thing that it adds up to be has got to be bigger than the two things that are being added up. That was probably more confusing than anything that I just said. But if you think about what I said, it kind of makes sense. Everybody watching? If it takes these two things right here to be a 7, to add up to be a 7, then that 7's got to be bigger than the two things that are being added up. Would you agree? Yeah. So if I had two line segments, okay? If I had two line segments, and let's say this was 3 and this was 4. If I put them right next to each other, side by side, what would they add up to be? They would add up to be 7. So the combination of these two being added together has to be bigger than either this one or this one. You see that? All right, so let's put them a little bit, instead of crooked like that, let's put them right next to each other. So let's say, where's my thing? Right there. So let's say that was 3. Tell you what, I'm going to copy. Oops, I don't want to do that. Sorry. Give me a second here. Copy, paste. I want to keep it on the same line. All right, and I just want to extend this out a little bit. All right, we'll say that's 4. Okay, that's 3, that's 4. I don't know exactly if it's 3 and 4 or whatever, but we'll just call it that. Okay, you watching? So watch this. Let's make them different colors too. There we go. So if I took this and I moved it to there, what's the whole thing? The whole thing's got to be 7, okay? So that means this one and this one have to be smaller. Both of them individually, the white one and the blue one, have to be smaller than what? 7. Everybody see that? So that's what the comparison property is basically telling you, okay? Either one of these has to be smaller than 7. If 7 equals 3 plus 4, and you can put any numbers in there, any numbers that fit this. So that's the comparison property. That's what they're trying to show you. That's going to help us do some geometry. We kind of alluded to it a little bit right here, but we're going to do a little bit more. So this time, we're going to use that with a triangle. So let me draw a triangle. And I'm actually going to extend one of the sides to the triangle. So I'm not going to go all the way to the end. I'm going to go right here. Okay? I'm going to leave a little bit right here. And we've talked about this before. You remember this? This is an exterior angle. So let's do this. Angle A Call this C, call this B. All right? We've talked about this before. Remember the exterior angle is equal to the what? The sum of the, do you remember what the phrasing was, what the words were? The exterior angle equals the sum of the interior is part of it. You're right. You're on the right track. The exterior angle is equal to the sum of these are further away. Remember I talked about watching TV? What do you have in your hand if you're far away? Okay, it's the remote interior angles. Do you remember that? So that means that angle 1 is equal to the sum of the remote interior angles. So which angles are my remote interior angles here? Angles B and C, that's right. So I could write this, couldn't I? Angle B, what? Plus angle C. You with me? Okay, so that's old stuff, okay? No big deal. But we have a theorem. They call this, again, I don't care that you know the names of these theorems. I'll just write it, I'll shorthand it here. They call this the exterior angle inequality. So what is inequality? I should have said that at the very beginning of this thing. We know what stuff is equal to, right? 5 equals 5. That's an equality. Would you agree? But if they're not equal, if one is smaller than the other, or if one is bigger than the other, then it's a what? It's an inequality, okay? You with me on that? So that's why they named this inequality. So that's what we're going to talk about. We're going to talk about a comparison. Is one thing bigger than the other? Is it smaller than the other? Or is it equal? Are there any other choices? Like if I was going to compare two things, two numbers, two lengths, two angles, okay? Either one is bigger than the other, or one is smaller than the other, or the two angles or sides or whatever are equal to each other. Are there any other choices? No, there's no other choices. You got a big fancy name for that. I'm not going to worry that you know it, but it's called a trichotomy. All right, it's a word that people actually use every once in a while in real life, not even just talking about geometry. It's called a trichotomy. You got 3 choices. Why trichotomy? Tri meaning what? Try 3. That's right. You got 3 choices, okay? Everybody with me on that? All right. So what could we say here then? According to that comparison property that we did earlier, if angle B plus angle C adds up to be angle 1, what could we say about these? We could say that angle 1, let's compare it to just one of these. What would I say about angle 1? Angle 1, would it be equal to angle B? It'd be greater than, that's right. Angle 1 right here has to be greater than angle B. And angle 1 also has to be what? Greater than, what else? Angle C, very good. Do you see how that comparison property comes into play here? So that's what they're going to do. They're going to ask you, compare angle 1 to angle B. Is that bigger or smaller? Right? It's got to be bigger. And why? Because of that comparison property. So what this does, this exterior angle inequality theorem, that's a mouthful right there. There's no way I would probably remember that, and I don't expect you to remember it. But that's the theorem that says, it says the measure of an exterior angle of a triangle, that's angle 1, that's the exterior angle, is greater than the measure of either remote interior angles. So what this theorem right here is saying is, if you have an exterior angle, that exterior angle has to be bigger than that remote interior angle, and that exterior angle has to be bigger than what? That other remote interior angle. So angle 1 is bigger than B, angle 1 is bigger than C, all right, because B and C add up to be angle 1. Does that make sense? All right, so that's kind of important. Let's do another one. I don't recall a problem on a quiz or a test that is directly this, okay? But this is going to help us with some other things, like this next one. This next one you will see on a quiz or a test, all right? So this one's super important, so make sure you're awake for it. Got a few people nodding off. It'd be really nice if you stayed awake, but I guess that's your problem if you're not going to stay awake. This one is called the greater. Again, this is inequalities, so we're talking about stuff that's greater or less than. This is called the greater angle theorem. Okay? And we got 2 versions of this. let's do it like this. Just looking at my notes, seeing which one I want to do here. All right. So that's 13. That's 14. That's 12. This is angle L. This is angle M. And this is angle N. All right, let me read off the greater angle theorem. I'm not going to write it out for you. Just going to read it off, and we're going to use the picture right here to kind of help us understand what this means. But I will read it to you. But I want you to think about what it says. Don't let your mind wander. Think of other things. Don't think of the snow that's coming. Think of this right now, okay? It says, if two sides of a triangle are not congruent, do I have a triangle where two of the sides are not congruent to each other? Sure, none of them are congruent to each other, are they? All right, so the if part works for this. So if I got two sides of a triangle that are not congruent, then the larger angle is opposite of the larger side. Do you hear me? That's pretty self-explanatory. It's not that hard to understand. The larger angle, so if I asked you to put the angles in order from, let's go smallest to largest. Smallest to largest. Okay, so I want you to put the angles in order. So the first one is the smallest one, the second one is the middle one, and the third one is the biggest one. Okay. Yes. So let's take a look. Again, let me read the theorem again. Okay, it says the larger angle is opposite of the larger side. So which one's the largest side here? 14. Which angle is opposite the 14? Angle M. Okay, so what is angle M then? Where do I put it here? Do I put it first, second, or third? Put it third, because that's the largest what? The largest angle, because it's opposite the what? The largest side. So what do you think might be true? What angle do you think is opposite the smallest side? The smallest angle, which would be L. That's correct. All right, so if 12 is the smallest side, then you look across from it right here. So angle L is the smallest angle. So what goes here? Angle. Put the angle symbol. Now sometimes my L's and angles kind of look the same, but that's an angle L. And of course the middle one is what? Angle N. Right, so put the angle symbol. Can't believe how many times on a quiz or a test or something, you guys don't put the symbols, okay? I ask you for a triangle, and people just go ABC. Is that triangle ABC? No, okay? You don't know if it's angle ABC or triangle ABC. If I ask for a triangle, put a triangle. If I ask for an angle, then put an angle, right? I know a lot of teachers that mark the problem wrong if you don't put the symbol in front of it. And some of you guys will get a lot of problems wrong because you're not putting the symbol in front of it. So right here, don't just put L, N, M. Put angle L, angle N, and angle M. All right, you with me on that? All right, now we have another one. That's the greater angle theorem, okay? These are the angles in order. Let's do this before I go to the next one. I could also ask for you to put it in order from, what do you think? From larger to smaller, largest, right, to smallest. If you could do one way, you could do the other way. It should be pretty easy. It would be, yes. All right, so if you go from the largest, so which one's the largest angle here? Angle M. So angle M would go first. Which one's the smallest angle here? Angle L. So I'll put that on the end. And then, angle L. Put an L right if I can. Come on, this dumb pen. I keep clicking the button on the pen. Wish they wouldn't put that button on there. Anyway, angle L. And then, of course, what's in the middle one? Angle N would be in the middle. Okay? So they could ask you that either way. All right, so make sure that you read it. Make sure you read the quiz and see what order you're supposed to put this in. We got it? Okay. So we have another one. I tell you, yeah, let's just do a completely different one. So we got another theorem, and it's called the longer side theorem, and it's kind of like the opposite of what we just did. And I probably could have used that other triangle, but this is what I got written down, so might as well use it. So here's another triangle. This time, I don't tell you the lengths of the sides. I tell you, and it's not really drawn exact to scale. It's good enough. We'll just use it. This is 20. It's pretty close. Not quite, though. All right, so let's say we got this right here, and I'll call it ABC. So what do you think you could find now? Before, on that other one, they told you the lengths of the sides, correct? And you could find, not the lengths of the angles or the measure of the angles, but you could find which one's bigger, which one's smaller. Agreed? Look at this one. This time, they give you the measure of the angles. What do you think you could find now? The sides, that's right. And let's just take a wild guess. And by the way, they call this the longer side theorem. I'll write it down. Again, I don't really care that much that you know the name of it, but that's what they call it, longer side theorem. I just want you to understand what it's doing. So if they gave you 3 angles of a triangle, you should be able to tell me which one is the longest side, which one is the medium side, the middle one, or which one is the smallest side. Would you agree? So without just looking, because if I just looked at this and I didn't know those numbers, it may look like this side and this side are about the same because I didn't draw it very accurately, okay? But with these numbers, you should be able to tell me exactly which one's the smallest side, which one's the medium side, which one's the longest side, all right? So let's go from small to large, S to L, small to large. Everybody got that? Now, what am I finding now? I'm not finding the angles. Give it to me, Ben. I'll take it. I'll take it. What? Well, I love that. What? What? Get it at the end of the day. If you forget it, it's mine. All right, so what am I finding? The smallest what? The smallest sides, right? Okay, so which one is the smallest side on this triangle right here? AB. All right, so how do I label AB? A line segment. So put a little line segment over top of it. Let's jump to the largest one. Forget the middle one. Let's jump to the largest one. It's AC because look, 100 degrees is the biggest angle. So you look opposite the biggest angle and it's AC. So AC would be the largest. So obviously, which one's the middle one? BC. Line segment BC. Notice, I put the little symbol things over top of it. Okay, they're line segments. They're sides of a triangle. And of course, I could always ask for the other way. I could ask you from the largest side to the what? Smallest side. And that should be pretty easy. Again, the largest one is opposite the largest angle. So this would be AC. The smallest one would be opposite the smallest angle. That would be AB. Oh, forgot the line segment over top of it. And of course, the middle one's going to be the middle one on both of them. So on a quiz or a test, I could ask you to put it in that order. Everybody with me? All right, so that's pretty easy, isn't it? Let's see what else I got. Okay, let's just talk about these real quick. So here's a theorem. It doesn't have a special name or anything. I'm just going to draw a right triangle. So I want to draw a right triangle. Now, we've actually talked about this before, but we never really gave a reason for it. But now we're ready to give a reason for it. I'll tell you what I'm talking about here in a second once I draw this thing. So there's a right triangle. Let's just do this. I'm just call this ABC. What if I asked you, what is the largest side? And that's all I tell you. I don't even tell you the lengths of the sides. That's all I tell you. You got a right triangle. Okay, but you should be able to tell me which one is the largest side. Why AC? Well, you don't really know what the other two are, but you do know that these two add up to be 90, correct? So that must mean that 90 has to be bigger than A, and 90's got to be bigger than C. So tell me about that 90. 90 is the biggest angle in that triangle. It's always, on a right triangle, the right angle, the 90-degree angle, is always the biggest angle. You got that? Okay. So that means, which one's the biggest side? It's AC. Oops. All right, so it's line segment AC. We have a name for line segment AC. I think we've talked about that before. We have a special name for line segment AC, or side AC. It's the side that's opposite the right angle on a right triangle. Have we not talked about that before? Starts with an H. You got it. Have we talked about that in here, or maybe? Seems like we should have at this point of the year. Anyway, that's called the hypotenuse. So the hypotenuse is always the largest side of a right triangle. Okay? Doesn't matter what kind of shape your right triangle is, right? As long as you got a right angle in there, right? Could be really skinny, could be a little fatter, it could be isosceles, okay? It could be all kinds of stuff, all right? But the hypotenuse will always be the longest side. Why? What's the reason? If somebody asks you, what's the longest side of a right triangle, you would tell them what? The hypotenuse. And they said, okay, well, tell me why. And you can say what? Well, the hypotenuse is always opposite the 90 degrees, and 90 degrees is the largest angle. So the hypotenuse is always opposite the largest angle. Okay? So if anybody stops you on the street, you're ready for an answer. You don't think somebody's going to ask you that? Probably not. I might ask you that in the hallway, so you better be ready. All right? So anyway, the hypotenuse is opposite the right angle, and it's always the largest side. All right? That's what that theorem says, that first theorem says. And we got one more thing to talk about, and it's something that I think we've talked about before. So watch this. What if I have a line, and that line could keep going, it doesn't matter, and let's say I have a point somewhere. And I ask you to draw the shortest distance from that point to that line. Where would you draw it? Would you draw it to there? Would you draw it to there? What's the shortest length from this point right here to this line segment? Where is it? Oh, come on. How many times I say don't say straight down? Well, it doesn't have to be a bisector, but it's perpendicular. Perpendicular, okay? So look, the shortest distance, everybody hear me? The shortest distance from a point to a line is the what? It's the perpendicular distance, okay? So you draw it perpendicular, all right? So that would be the shortest, because if I drew it from here, if I drew it from there to there, guess what? That line is what? It's longer. And look at it. Formed a right triangle. What is that line right there? That's the hypotenuse, isn't it? And the hypotenuse is always the biggest side of that triangle. Would you agree? So that is not the shortest distance. All right? That right there is the shortest distance. It's kind of common sense, isn't it? Right? And you guys said straight down, so you're thinking in the right way. But again, I want you to use the right words in geometry. And the word is what? Perpendicular. Okay? I think that's it. I think I covered everything with this. So that means you have an assignment. Hopefully, you got an extra day to do it. But don't rely on it, because you never know what's going to happen with the weather. The weather people aren't exact. But it looks like we're going to get a little storm. But get this done, no matter what. Don't just say, well, I'm not going to have school tomorrow, so I'll just do it tomorrow. But on a snow day, are you really going to sit around doing homework on a snow day? Probably not. Okay? So get it done tonight. All right? Get it done tonight. Hopefully you can sit there and enjoy the snow coming down. Isn't that a good feeling, sitting inside your house and you look out the window? You got a light out the window or something. You see that snow coming down. Isn't that a great feeling? Especially if it's during the week and you know you're not going to have school the next day. All right. So get that done. Yep. All right. Get that done. That's your homework. So whenever we get back to school, whether it's tomorrow, if for some reason we have school tomorrow, this is due tomorrow. Okay? You got it? All right.